As New Horizons sails farther into the outer solar system, we begin to lift our eyes to the broader cosmos, toward the galaxies that surround our own. One such galactic neighbor has fascinated astronomers and dreamers alike: the Andromeda Galaxy. Found roughly 2.5 million light-years away from us, Andromeda is the closest spiral galaxy to the Milky Way, and it's enormous. You might imagine that something so far away would appear small in our sky, perhaps like a distant dot. But in truth, Andromeda is so large that if your eyes were sensitive enough, it would span 6 times the diameter of the full moon in the night sky. Why don't we see it with the naked eye in its full glory? The answer is light pollution and brightness. Despite its size, Andromeda is dim. Our atmosphere, city lights, and the human eye's limitations prevent us from fully appreciating this cosmic titan. But point a high-exposure camera at it, and you'll see sweeping arms of stars, dust lanes, and a brilliant galactic core. It's truly breathtaking. Andromeda stretches across 220,000 light-years, making it significantly larger than our own Milky Way, which is about 100,000 to 120,000 light-years wide. In fact, it contains over 1 trillion stars, more than twice the number in our galaxy. It is a behemoth, and it's heading straight toward us. Yes, you read that right. Due to the gravitational attraction between the Milky Way and Andromeda, these two galaxies are on a collision course. But before you panic, know this: the collision will happen in about 4.5 billion years, roughly when the Sun itself is expected to expand into a red giant. When these two galaxies collide, what will happen? Despite the term collision, it's unlikely that individual stars will crash into one another. The space between stars is so vast that even during a galactic merger, direct stellar impacts are extremely rare. Instead, the gravity of each galaxy will pull and distort the other, warping spiral arms, flinging stars into new orbits, and forming long tidal tails. Eventually, over the course of a few billion years, the two galaxies will settle into a new shape, likely an elliptical galaxy. Astronomers have even proposed names for this future structure, such as Milkomeda or Milkdromeda. Whatever we call it, it will be a completely transformed system. For anyone still living in that distant future, the night sky will be dramatically different. During the merger, Andromeda would appear as a swirling mass of stars, growing ever larger, dominating the sky in a celestial ballet. The view would be stunning, and a vivid reminder of the immense scales and slow-motion drama of the universe. But the importance of Andromeda isn't just about future collisions. Studying Andromeda gives us insights into galactic evolution, structure, and star formation. Because it is relatively close and large, astronomers can study its components in detail: individual stars, satellite galaxies, and globular clusters. In fact, Andromeda has a collection of over 20 satellite galaxies, similar to how the Milky Way has companions like the large and small Magellanic Clouds. These smaller galaxies are gravitationally bound to Andromeda and may eventually be consumed by it. One of the lessons we've learned from observing Andromeda and others like it is that galactic cannibalism is common. Larger galaxies grow by devouring smaller ones, an ongoing process of cosmic reshaping. Andromeda also gives us a comparative model to test theories about dark matter. Like the Milky Way, Andromeda rotates in a way that suggests the presence of an unseen mass, dark matter halos that extend far beyond the visible edge. Mapping these rotations and gravitational influences helps astronomers model the universe's composition, which is dominated not by stars and gas, but by dark matter and dark energy. What's even more exciting is the potential for planetary systems and possibly life within Andromeda. With over 1 trillion stars, many of which are similar to our Sun, the probability that Earth-like planets exist there is extremely high. While we have no way yet to detect life in that galaxy, Its sheer scale invites imagination and curiosity. Could someone be looking back? This possibility of mutual awareness across intergalactic distances feeds both science and science fiction. Though communication or travel to Andromeda is far beyond our current capabilities, the thought that life may be scattered not just across planets or star systems, but across galaxies, is one of the most profound ideas in modern cosmology. As our telescopes grow more powerful and our probes venture farther into space, we'll continue to gather data that illuminates the relationships between galaxies. Observatories like Hubble, the James Webb Space Telescope, and future missions will help us unravel how galaxies form, age, collide, and die. But for now, Andromeda remains a shimmering symbol of cosmic grandeur, a nearby giant that teaches us just how vast and dynamic the universe truly is. From the frozen plains of Pluto to the swirling arms of Andromeda, space is a storybook written across billions of light years and billions of years in time. Each chapter, each world, each galaxy tells us more about who we are and how we fit into the grand design. Stay with infinity beyond as we continue our journey. Next, we'll explore the mysteries of dark matter and how it sculpts galaxies like Andromeda and our own. When we look at Arakoth, we're essentially looking back in time, at an untouched remnant of the solar system's earliest days. The conditions under which this peculiar two-lobed object formed offer clues that challenge and refine our understanding of how planets came to be. To start, scientists estimate that the two lobes of Arakoth, known as Ultima and Thule, merged at a speed slower than 2 meters per second. That's slower than walking pace. Such a low-speed collision suggests that these bodies were in a gentle gravitational dance before they slowly merged. For this to happen, it's also likely that the two were tidally locked to one another prior to contact, showing each other the same face over and over again for millions of years. The fact that both lobes look so similar in shape and coloration further supports the idea that they formed in the same region of the early solar nebula. They likely coalesced from the same clump of material, meaning Arakoth isn't just a random pairing of two objects, but a natural, slow-born binary that became one. Before Arakoth received its official name from the International Astronomical Union, it was informally called Ultima Thule, a term used historically to describe lands beyond the known world. Though poetic, the name was replaced to reflect cultural sensitivity and honor the indigenous Powhatan Algonquian word Arakoth, meaning sky. The images from New Horizons revealed several bright regions on Arakoth's surface, especially around the neck, where the two lobes are joined. Scientists believe these areas could be composed of different ices or finer particles that settled into gravitational low points over billions of years. The neck region may have acted as a natural collection zone for such materials, creating a distinct, reflective band. There's also the matter of Arakoth's rotation. It turns once every 15.9 hours, a relatively slow spin for such a small body. Combined with its flattened, pancake-like shapes, this slow rotation suggests that Arakoth didn't undergo significant disruption or heating after it formed. No large impacts, no tidal stress, no resurfacing from internal forces. It is, in every sense, a cosmic fossil. And this fossil preserves a narrative that stretches back over 4 billion years. From a scientific standpoint, Arakoth validates the cloud collapse model of planetesimal formation. This theory proposes that instead of small objects bumping into each other over eons and gradually growing, bodies like Arakoth formed directly from a rapid collapse of pebbles and dust in a dense region of the solar nebula. In just thousands of years, astronomically instant, they became whole. This kind of formation explains why Arakoth's two lobes are so well matched in composition and appearance. It also supports the theory that larger planetary cores could have formed quickly, perhaps solving long-standing mysteries about how gas giants like Jupiter grew rapidly before the solar nebula dispersed. But Arakoth doesn't just teach us about ancient physics. It serves as a reality check. In our pursuit of interstellar discovery, we often focus on big targets, planets, moons, exoplanets. Yet this tiny YIM object billions of kilometers from the Sun reminds us that the smallest things may carry the oldest truths. Arakoth has no atmosphere, no heat, no magnetic field, but it has a story preserved in ice and rock, uninterrupted for billions of years. This is where missions like New Horizons shine brightest. They're not just about dramatic flybys or pretty pictures. They're about peeling back the layers of time, molecule by molecule, light curve by light curve, to understand how everything began. Think about what had to go right. A spacecraft launched in 2006, timed to meet a moving object discovered 8 years later, programmed years in advance to execute maneuvers autonomously, all to capture images of something no one had ever seen clearly before. And it succeeded. New Horizons' success with Arakoth demonstrates not just our technical abilities, but our patience, our willingness to commit to a journey that would take over a decade to bear fruit. It's a reflection of humanity's enduring curiosity. As we continue to analyze the data sent back by the spacecraft, scientists around the world are refining models of early solar system dynamics. They're revisiting theories of accretion, atmospheric development, and orbital evolution, all sparked by this little object that floats in the darkness, untouched and unassuming. And New Horizons? It's still moving, still alive, still listening. Now more than 50 astronomical units from the Sun, the spacecraft has entered the realm of interstellar exploration. It continues to collect data on the solar wind, cosmic dust, and the structure of the heliosphere, the invisible bubble that surrounds and shields our solar system from galactic radiation. These observations, while less flashy than planet flybys, are crucial. They help us understand where the Sun's influence ends and where the Milky Way begins. Just like Voyager 1 and Voyager 2, New Horizons is becoming a scientific ambassador to the stars. But what lies ahead? That depends on what it finds. New Horizons has the fuel and power to operate through the late 2020s or early 2030s. If a new target is discovered in time, it could attempt another flyby, perhaps of an even more primitive Kuiper Belt object. Even if that doesn't happen, its ongoing measurements will continue to shape our knowledge of the solar system's edge. So, what has Arakoth truly shown us? That the story of creation isn't just explosive and violent, it can also be quiet, graceful, and ancient. That the universe doesn't always build with fire. Sometimes it assembles with stillness, with cold, with gentleness, and sometimes that's enough to change everything we thought we knew. Join us in the next segment as we follow New Horizons further into the unknown, charting a path through interstellar space, guided only by the faint signals of a spacecraft that refuses to stop exploring. Only here, on Infinity Beyond. After the breathtaking success of the Pluto flyby, you might assume the mission was complete. But New Horizons had only just begun its deeper journey into the Kuiper Belt. Powered by a small but steady nuclear energy source called an RTG radioisotope thermoelectric generator, the spacecraft still had years of life ahead and the capability to explore even more remote destinations. Quickly after the Pluto encounter, the mission team at NASA began scanning the skies for another potential target, an object New Horizons could visit within its extended trajectory. But locating such a target wasn't easy. Kuiper Belt objects, KBOs, are incredibly dim, small, and distant. Even Hubble could only detect the faintest signals, light curves that revealed dips and peaks in brightness as these bodies rotated. Among the candidates, one stood out, a faint object designated 2014 MU69, later officially named Arakoth, a term from the Powhatan Algonquian language meaning sky. It was far smaller than Pluto, only about 36 kilometers long, but it held immense scientific value. Arakoth was thought to be a pristine relic of the early solar system, never having experienced strong collisions or internal heating. This made it a potential time capsule, preserving the original building blocks of planet formation. One of the most fascinating observations leading up to the flyby was Arakoth's stellar occultation. In this rare event, Arakoth passed in front of a distant star, briefly blocking its light. By observing the star's flicker from different locations on Earth, scientists could infer Arakoth's size, shape, and even details about its atmosphere, or lack thereof. Astonishingly, from this tiny flicker of starlight, they predicted that Arakoth was likely two lobes gently fused together, a contact binary. This insight turned out to be spectacularly accurate. On January 1, 2019, as Earth celebrated a new year, New Horizons made its closest approach to Arakoth, only 3,500 kilometers away, becoming the most distant object ever visited by a spacecraft. The images sent back to Earth were jaw-dropping. Arakoth was indeed composed of two connected lobes, resembling a misshapen snowman. Its reddish color hinted at tholins, the same complex molecules found on Pluto and Charon. Unlike Pluto, Arakoth showed almost no signs of geological activity or resurfacing. It was smooth, with few craters and no visible tectonic features. This confirmed that Arakoth had not been altered significantly since its formation over 4 billion years ago. In essence, it had remained frozen in time. The two lobes, now nicknamed Ultima and Thule, before the name Arakoth was chosen, were nearly spherical, suggesting they formed separately and merged slowly at low speed. This slow, gentle merging supports a model of accretion in the early solar system where small clumps of dust and ice gradually stuck together, eventually forming larger bodies. This idea contrasts with the more chaotic model of violent collisions and impacts that dominated earlier theories. Arakoth provided real-world evidence that in the calm outskirts of the solar system, planetary building blocks may have formed peacefully. Another discovery was Arakoth's surprisingly flat shape. It wasn't a simple sphere. Each lobe had a pancake-like compression, especially the larger one. Scientists speculated this could result from gradual collapse within a rotating cloud of gas and dust, offering a new perspective on how gravity and angular momentum shaped early celestial objects. New Horizons also revealed that Arakoth's surface was uniform in composition, with no obvious layering or differential erosion. This further emphasized its pristine nature, undisturbed for billions of years, untouched by internal heating, radiation melting, or large impacts. Despite being over 6.5 billion kilometers from Earth, the spacecraft successfully transmitted detailed imagery and spectral data over many months. It showed that even tiny frozen worlds in deep space could provide profound insights into how our solar system began. Arakoth's flyby wasn't just about one object. It represented the broader quest to understand the Kuiper Belt itself. This vast icy ring stretches beyond Neptune and may contain hundreds of thousands of ancient bodies. Each one is a chapter in the solar system's origin story, waiting to be read. For New Horizons, reaching Arakoth required precise navigation. Because of the low brightness and great distance, even minor adjustments were critical. The spacecraft's trajectory had to be fine-tuned with delicate thrusts, all based on data from telescopes billions of kilometers away. That it arrived so precisely is a triumph of engineering and interstellar planning. Today, New Horizons continues to operate, cruising deeper into the Kuiper Belt, scanning the region for dust, cosmic rays, and potential future targets. Though no additional flybys have yet been confirmed, its instruments remain active, and its mission continues. What we've learned from Arakoth challenges assumptions about planet formation. It suggests that in at least some parts of the solar system, growth was slow and serene, not violent and explosive. That has implications not just for our own solar system, but for how planets may form in exoplanetary systems as well. Arakoth showed us that even the smallest, coldest objects in our solar system can speak volumes. They remind us that history is written not just by giants like Jupiter or Saturn, but also by humble pebbles left undisturbed in the void. As New Horizons presses onward into the stars, it leaves behind a trail of enlightenment. Each flyby, each signal beamed across billions of kilometers, brings us closer to understanding where we came from and where we're headed. In the next segment, we'll dive deeper into the implications of New Horizons discoveries and what they reveal about the earliest days of our solar system's life. Only here, on Infinity Beyond. One of the most surprising revelations from the New Horizons mission was that Pluto has an active, dynamic atmosphere, albeit a very thin one. Compared to Earth, the atmospheric pressure on Pluto is vanishingly small. While Earth enjoys a surface pressure of about 1,013 millibars, Pluto's is only around 10 microbars. That's roughly 100,000 to 1 million times weaker. And yet, despite its near-vacuum conditions, Pluto's atmosphere is a source of scientific intrigue. What's more fascinating is how this atmosphere changes over time. Pluto's orbit is highly elliptical, meaning its distance from the Sun varies dramatically over its 248-year orbital period. At its closest, it gets even nearer to the Sun than Neptune. During this phase, the temperature slightly increases, causing frozen nitrogen, methane, and carbon monoxide on Pluto's surface to sublimate, turning directly from solid to gas, and feeding the thin atmosphere. Scientists theorize that at this point in Pluto's orbit, the atmospheric pressure could increase to as much as 18 to 280 microbars. That might not sound like much, but it's enough to create weather patterns, thin haze layers, and even slow winds. In fact, this atmospheric shift gives Pluto the rare distinction of having a seasonal atmosphere that breathes over centuries. As Pluto moves away from the Sun again, the gases condense back onto the surface, forming icy frosts. It's an ongoing, slow-motion breathing cycle, inhale and exhale, on a planetary scale. New Horizons detected more than just pressure changes. Its instruments observed more than 20 distinct haze layers in the atmosphere, extending up to 200 kilometers above the surface. These layers are not uniform, but are influenced by surface topography, such as mountains and cliffs, hinting at complex atmospheric dynamics. The haze particles scatter sunlight, creating Pluto's soft, bluish halo, a hauntingly beautiful sight captured during the flyby. These haze layers are likely composed of tholins, complex hydrocarbons that form when solar ultraviolet light and cosmic rays break apart methane molecules. The resulting fragments recombine into reddish, sticky molecules that eventually settle on the surface, contributing to Pluto's distinctive color. These tholins are not just visual markers. They could also hold chemical clues about the processes that shaped the early solar system. The atmospheric temperature, too, was unexpected. Models had predicted warmer layers high in Pluto's atmosphere due to solar heating. But New Horizons found the opposite. Upper atmospheric temperatures were colder than expected. This puzzled scientists and suggested that some unknown mechanism, perhaps involving hazes or exotic cooling agents, was absorbing energy and radiating it away. Interestingly, despite its fragile nature, Pluto's atmosphere exhibits aerosol formation, a process often seen on planets like Earth and Titan. This indicates that even with low pressure, complex physical and chemical interactions are occurring. It reinforces the idea that Pluto is not a static, frozen relic, but a living world, actively responding to its solar environment. Looking down from space, the atmosphere's interaction with the surface becomes even more compelling. One example is how light scattering from hazes creates long shadows and soft edges around mountainous terrain. These interactions not only make for stunning images, but they also help scientists map topography and composition from orbit. Pluto's climate is also influenced by its axial tilt of 120 degrees, far more extreme than Earth's 23.5 degrees. This tilt causes Pluto to experience extreme seasons. During some parts of its orbit, one hemisphere is plunged into years-long darkness, while the other basks in continuous sunlight. These extremes impact both surface temperature and the sublimation-condensation cycles of its icy components. What about Pluto's ability to retain this atmosphere? Despite its small mass, Pluto manages to hold on to a temporary atmosphere due to its cold environment. The low temperatures reduce molecular velocity, allowing gases to linger longer than they would on warmer bodies of similar size. However, the solar wind, the stream of charged particles from the sun, poses a constant threat, stripping away atmospheric particles over time. New Horizons measured this escape rate and found that Pluto is gradually losing its atmosphere, although much more slowly than anticipated. Instead of a violent outflow, it's more like a gentle leak, steady but manageable over astronomical timescales. This finding challenged previous theories that Pluto would lose its atmosphere entirely during the cold part of its orbit. Adding another layer of mystery, New Horizons detected ionized nitrogen in Pluto's upper atmosphere, hinting at complex interactions with solar radiation. These ionized particles form a plasma tail, much like a comet, that extends into space and further connects Pluto's behavior to other small, icy bodies. All of this tells us one crucial thing: Pluto is not dead. Despite its size, despite its distance, and despite its classification as a dwarf planet, Pluto is vibrant and dynamic. Its climate, however faint, breathes and evolves. Its atmosphere, though nearly invisible, dances with light and shadow. And its relationship with the sun, however weak, still drives cycles of transformation that echo through the centuries. In a way, Pluto reminds us of ourselves. Fragile, small, and seemingly insignificant from a cosmic perspective, but full of wonder, motion, and complexity when observed closely. As New Horizons continues to transmit data from the outer reaches of the Kuiper Belt, we are reminded that no world is too far, too cold, or too small to matter. Every celestial body holds a story, and Pluto's is one of unexpected vitality and celestial elegance. But there is still so much more waiting beyond Pluto. The Kuiper Belt stretches endlessly into the darkness, filled with icy objects that may tell us more about our solar system's origin, and possibly even about how life began. What other secrets does the Kuiper Belt hold? And how far can humanity reach? Join us next time as Infinity Beyond takes you deeper into the cold frontier, where the known ends and true exploration begins. Sometimes, it's not just about the science or the discoveries. It's about the journey itself. And with Pluto, what a journey it has been. From blurry Hubble images to breathtaking close-ups, from debates over its planetary status to becoming one of the most intriguing worlds we've explored, Pluto has captured the imagination of a generation. And if watching this series has sparked curiosity, questions about Pluto's orbit, its surface chemistry, or its role in the wider solar system, you're not alone. Every mystery Pluto reveals only deepens our interest. And that's the beauty of space exploration. It answers questions while creating new ones. Pluto, with its wildly elliptical orbit and 248-year journey around the Sun, moves in a rhythm entirely its own. Sometimes closer to the Sun than Neptune, Sometimes drifting nearly 6 billion kilometers away, it exists at the frozen edge of our solar system, a sentinel to the deep unknown. The more we learn about it, the stranger and more beautiful it becomes. Its mountains made out of water ice, its plains of frozen nitrogen, and its mysterious reddish tholins tell a story of slow, silent transformation. A world where geology moves not with earthquakes, but with the creep of glaciers. A place where sunlight takes 5.5 hours to arrive, and the sun looks no brighter than a full moon does from Earth. And yet, it's there, spinning quietly with its moon Charon, locked in a gravitational dance, an atmosphere that freezes and evaporates in long, slow breaths. Moons that tumble chaotically through the sky, features on its surface named after legends, myths, and beloved fictional characters. Cthulhu, Tombaugh Regio, Sputnik Planitia, each name a tribute to human creativity and our instinct to map and name the unknown. More than a destination, Pluto has become a symbol of perseverance, of looking deeper, of not being satisfied with a dot in the distance, but striving to see it up close. That's what New Horizons gave us. Not just science, but vision. This world, so remote, so unvisited for so long, reminds us that mystery still exists in our cosmic backyard. We haven't seen it all. We've barely scratched the surface. And just because a place is distant or difficult to reach doesn't mean it isn't worth the effort. In a universe filled with noise and distraction, Pluto speaks in a whisper. But what it says is profound. It reminds us that the solar system isn't just 8 or 9 planets orbiting in tidy circles. It's messy, dynamic, evolving. It's filled with places like Pluto, small, cold, but rich with information about where we came from and how worlds are built. The flyby of Pluto wasn't the end of a mission. It was the beginning of a legacy. New Horizons changed the way we view dwarf planets, redefined the boundaries of planetary science, and opened the door to new missions beyond Neptune. Today, planetary scientists talk seriously about returning to Pluto, perhaps to orbit it or even land. The data returned by New Horizons only fuels the desire to know more. What lies beneath Sputnik Planitia? Could a subsurface ocean exist? Is there cryovolcanic activity still shaping the surface? We don't have all the answers, but we've taken the first step. And that's what makes space exploration meaningful. It's not about finishing the story. It's about turning the first page. Pluto taught us to keep going. That curiosity is reason enough. That wonder is a compass worth following. So whether you're an aspiring astronomer, a lifelong space nerd, or just someone who happened upon this video by chance, know this: you are part of the journey. Your curiosity adds fuel to the engines of discovery. Your questions lead to missions, and your imagination makes exploration worthwhile. This is Pluto, a world of contradictions. Cold but active, distant yet familiar, diminished in title but grand in mystery. It orbits quietly at the edge, untouched by fame or politics, unconcerned with classification. It is what it is, a strange and beautiful world, and a mirror that reflects both the universe's vastness and our desire to understand it. And if you ever find yourself wondering why we explore, why we send spacecraft to places so far away they feel like fiction, think of Pluto. It waited 4.5 billion years for someone to visit. And when we finally did, it welcomed us with a heart. In our final segment, we'll reflect on the incredible engineering that made the New Horizons mission possible, and what it tells us about humanity's capacity to dream big, build well, and reach the stars. Only here, on Infinity Beyond. In 2015, a wave of exhilaration swept through the global space community. For decades, Pluto remained a distant, fuzzy dot on the edge of our solar system, a mysterious world we knew very little about. Up until that moment, the best image we had of the Pluto system came from the Hubble Space Telescope. But even Hubble, with all its advanced optics, could only show us a blurry, pixelated version of this icy dwarf planet, tiny, dim, and barely distinguishable, with some color variation at best. That all changed dramatically when NASA's New Horizons spacecraft finally reached Pluto after an incredible 9-year journey across nearly 5 billion kilometers of space. This was no ordinary mission. It was a historical moment. For the first time, humanity could gaze upon Pluto and its moons in breathtaking detail. It was as if we had finally pulled back the curtain on a long-lost part of our cosmic backyard. What exactly did the New Horizons probe discover? Before we dive into those jaw-dropping revelations, let's talk about why this mission was so important. Pluto was once classified as the 9th planet in our solar system. However, in 2006, it was demoted to dwarf planet status, sparking fierce debates in both scientific circles and public forums. Despite this downgrade, Pluto remained an object of intense fascination. It symbolized the mysterious frontier of our solar neighborhood, the gateway to the Kuiper Belt. This brings us to the Kuiper Belt itself, a vast icy region of the solar system beyond Neptune, teeming with dwarf planets, comets, and remnants from the solar system's formation. Pluto is one of the largest known objects in this region, making it the perfect target to better understand this mysterious belt. But due to its extreme distance from Earth, getting there was a formidable challenge. So how did New Horizons manage it? To reach Pluto before the 2015 flyby deadline, NASA had to act fast. Engineers and scientists launched the spacecraft in January 2006 aboard an Atlas V rocket, one of the fastest departures from Earth in the history of spaceflight. In fact, New Horizons passed the Moon in just 9 hours. That's about 10 times faster than the Apollo missions. After this record-breaking launch, New Horizons used Jupiter's massive gravity to slingshot itself deeper into space in 2007, shaving years off its journey. But even with this gravity assist, the spacecraft still had an incredibly long road ahead. For much of the journey, New Horizons remained in hibernation mode to conserve energy and minimize wear on its systems. It would awaken periodically for systems checks, but mostly it slept while drifting through the cold, dark void. It wasn't until late 2014 that the spacecraft finally began to wake up for its final approach. As it neared Pluto, mission controllers at NASA's Johns Hopkins University Applied Physics Laboratory started preparing for the most crucial phase of the mission. On July 14, 2015, the world watched as New Horizons made its closest approach to Pluto, just 12,500 kilometers from the surface. It flew past at a speed of nearly 14 kilometers per second, snapping thousands of high-resolution images and collecting data on everything from Pluto's thin atmosphere to its icy terrain. And what we saw was nothing short of revolutionary. Pluto, once thought to be a dull and barren rock, turned out to be a geologically active world with mountains made of water ice, vast nitrogen plains, and possible signs of subsurface oceans. The most iconic image of Pluto featured a large heart-shaped region officially named Tombaugh Regio, in honor of Clyde Tombaugh, the astronomer who discovered Pluto in 1930. The heart-shaped area wasn't just photogenic, it held scientific clues. Half of it, called Sputnik Planitia, was a vast nitrogen ice plain with almost no craters, suggesting that it was geologically young, perhaps even less than 10 million years old. This indicated that Pluto was still undergoing internal processes, despite its distance from the Sun. New Horizons didn't just study Pluto. It also revealed details about its 5 known moons. Charon, the largest, is so massive relative to Pluto that they actually orbit a common center of mass in space, effectively making them a binary system. Charon's surface is marked by deep canyons and dark regions, showing evidence of tectonic activity and possibly ancient cryovolcanoes. This kind of data transformed our understanding of what a dwarf planet could be. Pluto wasn't a lifeless ice ball. It was dynamic, complex, and surprising in almost every way. It forced scientists to reconsider assumptions about planetary classification, geology, and even the potential for life in distant icy worlds. Even more impressively, New Horizons achieved all this during a brief flyby lasting only a few hours. Because it was traveling so fast, it couldn't slow down or enter orbit around Pluto. All of its observations had to be perfectly timed and executed with surgical precision. And they were. After the Pluto encounter, the spacecraft continued its journey into the Kuiper Belt. In 2019, it performed another flyby, this time of a much smaller object called Arrokoth, formerly known as Ultima Thule. Once again, New Horizons sent back invaluable data, further unraveling the mysteries of the early solar system. To this day, New Horizons remains one of NASA's most remarkable deep space missions. It showed us that even the coldest, most distant corners of our solar system can be full of surprises. And perhaps more importantly, it reminded us that exploration never truly ends. It just moves a little farther into the unknown. Stay with us as we dive even deeper into the story of New Horizons, Pluto, and the mysterious frontier of the Kuiper Belt, right here on Infinity Beyond. The discoveries made by New Horizons during its brief encounter with Pluto only scratched the surface of the dwarf planet's mysteries. One particularly fascinating feature revealed was Sputnik Planitia, a vast plain of nitrogen ice so smooth and unblemished that it resembled a cosmic skating rink. But a closer look unveiled something even more remarkable: massive polygonal patterns covering the surface, each several kilometers across. These patterns weren't random. Scientists believe they are convection cells, regions where warm nitrogen ice from below rises, cools at the surface, and then sinks again, creating a slow-moving churn not unlike what happens in Earth's mantle or in a lava lamp. These slow convection currents drive glacial movement in Sputnik Planitia, shaping troughs, pit, and ice flows that pour into the surrounding mountains. In this frigid alien world, even the ice behaves like living matter, shifting and flowing over geological time. Some scientists theorize that Sputnik Planitia may have formed in the aftermath of a massive impact. A comet or asteroid could have struck Pluto, creating a deep basin that was later filled with layers of nitrogen ice. Interestingly, the plain sits almost directly opposite Pluto's largest moon, Charon, which hints at a gravitational relationship between the two. Over time, the impact basin may have moved due to tidal forces and realigned itself in a stable position due to Pluto's interior mass distribution. Even more compelling is the possibility that beneath the surface of Sputnik Planitia lies a subsurface ocean of liquid water, kept from freezing by residual heat from Pluto's formation or radioactive decay. This internal ocean hypothesis makes Pluto even more intriguing, not just as a frozen relic of the solar system, but as a world with the potential for complex chemistry and perhaps even the basic ingredients for life. As New Horizons passed by, it also mapped the atmosphere of Pluto. Once thought to be negligible, Pluto's atmosphere surprised scientists with its layered haze and complex structure. The spacecraft detected a thin layer of nitrogen, methane, and carbon monoxide extending hundreds of kilometers above the surface. These gases scatter sunlight and create a bluish glow around Pluto, especially when viewed in backlight. The haze itself isn't just a beautiful sight. It reveals a rich photochemistry occurring in the upper atmosphere. Sunlight breaks apart molecules like methane, allowing them to recombine into more complex hydrocarbons called tholins. These reddish compounds eventually fall to the surface, giving Pluto its distinct brownish-red color. Remarkably, some of these processes may be similar to those that occurred on early Earth. reinforcing the idea that even the most distant worlds can offer clues about our planet's past. Meanwhile, Charon, Pluto's largest moon, had surprises of its own. Larger than any other moon relative to its parent body, Charon shares a unique gravitational relationship with Pluto. They are tidally locked to each other, always showing the same face, and orbit a common center of mass located outside of Pluto's surface. In effect, they're a binary dwarf planet system. Charon's surface was found to be drastically different from Pluto's. Lacking an atmosphere, it features large canyons and troughs that stretch across its surface, some of them deeper than the Grand Canyon. The northern hemisphere is marked by a dark reddish cap, nicknamed Mordor Macula, likely caused by methane escaping from Pluto and transforming into tholins after settling on Charon. Tectonic features on Charon suggest internal stretching, which could mean the moon once had a subsurface ocean that froze and expanded, cracking the surface. The presence of such geological activity in a place so far from the sun was unexpected, and it reminded scientists that even small, icy worlds could be dynamic and evolving. The data sent back by New Horizons continued to astonish for months after the flyby. Because of the spacecraft's immense speed and the limited communication bandwidth with Earth, it took over a year to transmit all the collected data. But each new image and measurement brought fresh revelations, from the complex layering of Pluto's ice cliffs to possible cryovolcanoes, ice volcanoes that once erupted slushy water, ammonia, or methane. What made all this more impressive was the fact that New Horizons did it all during a flyby. The spacecraft didn't slow down or enter orbit. It had one chance to capture data as it sped past Pluto at over 14 kilometers per second. Every camera angle, every sensor activation had to be pre-programmed with split-second precision. There would be no second chances. Once the Pluto mission was complete, New Horizons wasn't done. NASA extended the mission to explore the Kuiper Belt, sending the spacecraft even farther into uncharted territory. On January 1, 2019, it flew by a small, peanut-shaped object known as Arrokoth, formerly Ultima Thule. This distant world, located over 6.5 billion kilometers from Earth, is one of the most primitive bodies ever observed. Arrokoth offered a glimpse into the solar system's ancient past. Formed from the gentle merger of two smaller objects, its surface was almost entirely unchanged for billions of years. It confirmed the theory that Kuiper Belt objects formed through slow, delicate processes rather than violent collisions. Studying Arrokoth gave scientists invaluable insight into how planets may have begun forming in the early solar system. With each new milestone, New Horizons continued to challenge expectations. It showed us that distant doesn't mean dead. Even tiny worlds at the frozen edge of our solar system are shaped by complex geology, chemistry, and physics. They're places of history, mystery, and potential. And as it continues to cruise through interstellar space, New Horizons reminds us of the boundless curiosity that drives exploration. It is a silent emissary, still beaming data back to Earth, whispering tales of worlds we had once dismissed as insignificant dots. What lies next for New Horizons? What secrets still wait in the deep dark of the Kuiper Belt and beyond? Stay tuned as Infinity Beyond brings you closer to the farthest reaches of the known solar system and what lies just beyond. Among the many surprises Pluto had in store, one of the most mesmerizing was its landscape of methane dunes. Yes, dunes, on a world so cold that gases freeze and rocks are made of ice. It's hard to believe, but even in Pluto's tenuous atmosphere, wind still shapes the surface. These dunes, discovered near the boundary of Sputnik Planitia, span a region roughly 2,000 kilometers wide, making them comparable in scale to massive desert systems on Earth, like the Taklamakan Desert in China or Death Valley in California. But unlike earthly sand dunes formed from silica grains and whipped by air currents, Pluto's dunes are composed of tiny particles of methane ice, blown by exotic and extremely weak winds. So how do these particles become airborne in such a thin atmosphere? The answer lies in sublimation, a process where solids transition directly into gas. On Pluto, as sunlight warms the nitrogen ice that blankets the surface, the ice sublimates and creates tiny updrafts. These gaseous bursts carry lightweight methane grains up into the atmosphere, and eventually they settle and accumulate along ridges and plains, forming transverse dunes with regular, repeating patterns. This discovery was astonishing, not only because it proved that Pluto has active aeolian, wind-driven processes, but because it showed that even the weakest atmosphere can still reshape a world. In an environment where the surface pressure is less than a millionth of Earth's, the presence of dunes testifies to a subtle but ongoing interaction between surface and atmosphere. And this wasn't the only surprise in Pluto's dynamic surface environment. New Horizons also captured evidence of possible cryovolcanism, ice volcanoes that may have once erupted ammonia water slush instead of molten rock. These features suggest that Pluto has, or had, internal heat, potentially sustained by radioactive decay in its rocky core. If this heat persists, it could allow subsurface oceans to exist today, protected beneath layers of ice. In fact, the idea of a hidden ocean beneath Sputnik Planitia, an ocean rich in ammonia or salts that lower the freezing point of water, has become a hot topic in planetary science. Such oceans may even provide the chemical conditions necessary for primitive life. So yes, Pluto, a world we once thought lifeless and frozen solid, might be more biologically promising than some of the larger moons in our solar system. All of this, the dunes, the atmosphere, the ice volcanoes, the possible ocean, is part of what makes Pluto so extraordinary, and none of it would have been known without the New Horizons mission. Let's take a moment to recognize the engineering brilliance behind this spacecraft. Launched in 2006, New Horizons was designed for one thing: speed. It left Earth faster than any spacecraft before it, reaching the Moon in just 9 hours. In 2007, it used a gravity assist from Jupiter to slingshot toward Pluto, trimming years off its travel time. Then, for much of its 9-year journey, it slept, entering hibernation to preserve energy and reduce wear on its systems. Every so often, it would wake up to receive software updates, calibrate instruments, and verify trajectory. This precision was essential. New Horizons would get only one shot at Pluto. When it finally reached its target in July 2015, it had just hours to collect data. Every camera angle, every instrument sweep, every byte of storage had to be pre-programmed. There would be no do-overs, and it worked flawlessly. From over 4.8 billion kilometers away, it transmitted detailed images, atmospheric readings, and topographical maps. It continued its journey, flying by Arrokoth in 2019, and today it remains active, pushing deeper into the Kuiper Belt and toward the edge of the heliosphere. New Horizons has become more than just a spacecraft. It's a symbol of what humanity can achieve, of how far we're willing to go for knowledge, beauty, and perspective. Its legacy will live on. Future missions may return to Pluto with orbiters, landers, or even cryobots designed to explore subsurface oceans. What started as a reconnaissance flyby may one day evolve into deep planetary science, perhaps even the search for microbial life. And in the meantime, New Horizons still whispers data back to us, slowly, faintly, but faithfully. It reminds us that space is not empty. It is filled with places that challenge our assumptions, humble our intellect, and ignite our imagination. So let us never stop asking questions. Let us never stop seeking the unknown. Let us keep going, beyond Pluto, beyond the Kuiper Belt, beyond everything we think we know. Because somewhere out there, waiting in the dark, is the next great discovery. Only on Infinity Beyond.